Next is a request to help with exercise 4, which is very similar to exercise 8.3. So let's go take a look at what we received and see if we can't get it fixed up. All right, so here we have a function with inputs a plot title and plot name. Okay. Initial concentration of A, B, D, and U. Good. Gas constant, temperature. Is that the activation energy? Yeah. Okay. Activation energy. So you compute my rate constant. That's good. Activation energy of rate 2. Compute the rate constant. Good. So it looks like we're going to set it up just like the last problem. So you have a vector of taus. Fine. Vector of A, B, D, and U to collect concentration of A, B, D, and U. Stoichiometric coefficients. Okay, so notice one issue here. So first reaction should be A and B reacts to form D, my desired product. Second is A and B react to form my undesired product. All right, initially I had 0 and 0 there, so there'd be no product being made in my second reaction. Okay, so got that fixed. Then this should, okay, having just looked at your 8.3 code, this should be good. Okay, let's just glance at concentration 1 again real quick. Yeah, first order A and B. Yeah, so having just looked at your good. Solve and collect, that's good. Okay, selectivity. Again, you're storing these in variables D and U. All right, so this would be D, and then the vectors would be D period divided by U. Fractional conversion. So again, your notation is CA underscore naught minus CA is actually A. Okay, so it's just a little subtlety with your notation. I'm going to comment out the selectivity of fractional conversion here because just like at the last problem, really should put those in separate plots. Okay, so I'm not going to do that exactly here. I'll leave that up to you. But let's just see if those little changes get this working. Okay. So I save that. Go to my command. Never seen that before. So let's maximize. Let's run. Okay. So when I ran it here, so we're told you have a non-square system. So that's telling us you have more equations than unknowns, or unknowns than equations. Okay, so let's look at this quickly. That's concentration of A, B, D, and U. Those are all scalars. These are all scalar quantities as well. I make sure we're referring to tau I. CV is a vector. I'm just trying to look to see if anything up there is out of place. So now if we look at, geez, there's no 4 here. So this is where lining things up could be incredibly useful in your code. So you could keep track of all these things. So yeah, that comment's right. There is no, then you're missing an end statement here. So somehow your for statement got goofed up. Okay, so something's still not right. But now we just have a legend error. Okay, so let's look at this again. Alright, so now we have this for loop for I equals 1 to length tau. Okay, no need for a semicolon here. Each iteration you pass tau I. That's good. You solve for A, B, D, and U. Okay, that's fine. These are just underlined in red because you don't use them. A, B, D, U. Okay. Let's check 1 minute. Okay, so my per-exponential term here has units of inverse seconds. So our time is actually in unit of time is actually minutes. So let me convert that back to minutes. See if that has any sort of effect on things. Let's see. I'm still having a plot issue. So is the issue possibly, are you missing a hold on? So there's nothing up top there. Yeah. So I'm missing a hold on. So what they're telling us is you only have one set of data because you don't have hold on, so these 3 are deleted by the time you get to tau u, and you're trying to label 4 sets of data. So let's see, that should take care of the legend issue. Okay, this looks good. Then again, this came up yesterday. There's something not quite correct with the way the problem is set up, right? And so let's just look out to like 80 minutes. Okay, but it kind of talked about this yesterday. With what appears the subtle issue is in the provided rate expressions. All right, so that looks good, right? And so with that, I mean, your code's working. Then I would tell you to refer to kind of the screencast yesterday, debugging code, because what you actually need to do to solve this problem is you don't need to loop over a range of taus, but you're given a very specific tau. All right, you're told that you have a reactor that's 25 gallons, and you have an inlet flow rate of 12.5 gallons per minute. So you're given tau. Tau is this divided by that. All right, so basically you want to solve for the concentration of A, B, D, and U for tau of 2, right? So you just need to solve for tau of 2 minutes, get A, B, D, and U, okay? And then with that very specific tau, calculate selectivity for that tau of 2, and then fractional conversion of the limiting reagent, fractional conversion of A. All right, so all you need to do is solve for the case of tau is 2. And I mean, if you wanted to, you know, I won't say cheat for lack of a better word, but you know, you could change that upper bound to 2 and run and see what those final values are. But you know, plotting's good. So I'd say take a look at the screencast yesterday, how we patched up the code. You can plot the entire range. Then you know, try and resolve just for that specific case of tau is 2 and plot that on the graph, and then also return those selectivities, right? And so that's where that subtle error in the rate functions, which causes unphysical behavior at high times, at the end of the day is okay for the problem because we're only interested in solving for that case of tau is 2. All right, so hopefully that at least gets you set up with your code working. But then again, look back at the problem statement and read it because you only need to solve for the case of tau is 2.